sheet open and chapter 3, section 1. If you can see my screen, then maybe you don't have to do a split screen with your textbook. But if you have your textbook open, you are already starting to prepare for like a quiz. If you don't have a textbook open, then you tend to drift off much faster, so stay engaged. I'm going to highlight a few things in my textbook. If you highlight in your textbook, you're more engaged and you will learn more. So how are you doing on your quizzes is sort of a direct result on how you start a unit. How focused are you? I know you're focused on the night before a quiz, but that's the wrong way to go about it. Somebody said, oh my gosh, I studied for 2 hours last night and I got like a C. And then there are those that probably didn't even study the night before and got an A. So it's not the amount of time, and if you spend your time at the very end trying to understand things, that's the wrong approach. So really, if you haven't made the switch yet to understand how to be a good student, it is staying on top of your content as we go. So after we go over 3 pages in the textbook, if it's fuzzy to you, then open this up before our next class and look it over. Read the textbook on your own. This is really a reading guide. It's not fill in the blank. If all you're doing is plopping words in there, you might not understand the whole story. So it's not that much reading. It probably only take you 10 minutes, but it's where the A students really get a leg up on understanding the material. So we'll fill in the blanks, but also keep in mind that it's more than that. It really is your life story and how you're made. So let's get to what is this thing about organic? Question number 1. Why is this molecule that you see over on the left-hand side organic? So over in the textbook, it says the definition of what an organic compound is. So I'm going to highlight that. What is the atom that you have to have in there in order for it to be called organic? What is it?
Hydrogen.
I heard hydrogen. Anything else? Carbon. It's really carbon. Carbon molecules are called organic. And cho, chon, chomp, all of our macromolecules, carbs, fats, proteins, and DNA, it starts with C, carbon. That's the backbone. In the last unit, we learned that carbon needs a lot of bonds. Anyone recall how many bonds carbon needs to have? And that picture right there is the clue. Count how many lines are leaving the C inside of question number 1. How many lines?
Just one. There's one.
Right here. How many lines are leaving each carbon? Here's another picture in the textbook. How many lines are leaving carbon? 4. It needs 4 bonds. What's its atomic number? Can you tell? It has 4 electrons in its valence shell. It needs 4 more. How many are in the shell before it? 2. So this has 6 atomic number. It has 6 electrons and 6 protons and 6 neutrons. But the key here is that it needs 4. That's a lot. So it's like a tinker toy, right? If you are putting together these different connects and building a structure, because it needs a lot of bonds. That's why it is the backbone of all of our molecules. We are said to be carbon-based life forms. The backbone of all of our large molecules have carbon, and then usually carbon is attached to itself and just runs for thousands of carbons connected.
They can even roll back on themselves and form rings. That's what our sugars are. Our sugars are 5 or 6 rings. So you see down here, it can form ring structures. It can form branches. It can form single bonds. It can form a double bond to itself. And it can even form a triple bond in some cases. So we'll get down to that. So number 1, that's pretty easy. It's organic if it contains carbon. And then usually there's a lot of hydrogens attached to carbon, as you can see all around here. What kind of bond is holding all of these together? Is it an ionic bond, covalent bond, or both? All solid lines are covalent bonds. So there's no dashed lines here. That would be a hydrogen bond. Because there's a lot of hydrogens, when chemists write the structure, all they have to do is draw the lines. At every corner, there's a carbon. So it's much faster than drawing all of the lines for the bonds to hydrogen and then drawing hydrogen. So to draw that, they're just going to draw like that. And that's the structural ring of sugar. And then at each corner, there's a carbon. And if you don't write down the other bonds, there should be 4 lines to every carbon, right? So there would be one there and one there and one there and one there. Guess what's attached to that? Hydrogen. And you just don't have to spend all the time to write all that. If you just draw the ring structure, and if everything else is hydrogen, you don't have to write anything else. All right, so let's go back here, and we are all carbon-based life form. List 3 properties of carbon that make it ideal element. Let's see where it says that. What's the answer to this? Number 1, carbon can form how many bonds? 4, because it's missing 4 electrons, because it needs 4 more electrons to fill its valence shell, its outermost electron shell. So that was number 2.1. Carbon-based molecules can vary in the what? Can vary in the length. They can be 2, they can be 3, they could be 10,000 carbons long. That's why they're called macromolecules, because they get to be ginormous. And 2.3, carbon can form covalent bonds with atoms to itself with atoms of other carbon. Number 2, which leads to a great diversity in number or arrangement. So the word arrangement was right. I saw it just a second ago. There it is. An arrangement of their carbon skeleton. So what is meant by a molecule's carbon skeleton? carbon skeleton means that carbon is the main molecule connected to itself. The carbon skeleton refers to the carbon and arrangement of blank atoms in a molecule. Structure. The arrangement of the structure. So I'm highlighting this word called an isomer. So different structural arrangements are called isomers. So we're on question number 3. The carbon skeleton refers to the length and arrangement of the structure of atoms in a molecule. Do you know the answer for question number 4 at the bottom? We're on it right now. If you haven't highlighted the word isomer, the molecules would all be isomers because carbon and hydrogen form 4 covalent bonds with each other. And they want you to use the word polar or nonpolar. So let's take a look at this. Polar, they want us to use the word polar or nonpolar. What is polar? Ani, do you know what polar means?
When the electrons aren't shared.
Right. So you have a positive side and a negative side. Do you see, is there a positive and negative side on this molecule? It's got hydrogen all the way around it. Hydrogen is slightly positive, right? When it's bonded, because its electron is in the line and its proton is hanging out there. So this is not polar because it doesn't have a negative side. This isn't polar, it's got hydrogen all around it. This is not polar because it has hydrogen all around it. Not polar, not polar, not polar, not polar. So I think we can answer the question now at the bottom of question 4. The molecules would all be isomers because carbon and hydrogen form non-polar covalent bonds with each other. Now I'm at the bottom of page 1 in the textbook, and there's one more key word right here. It says hydrocarbons. And if you hover over that, it gives you the definition that it contains only carbon and hydrogen, but as always, the textbook really gives you the answer of what that term is in the sentence itself. So I'm going to highlight that. And there's the answer for question number 5. This type of molecule is a hydrocarbon because it only has carbon and hydrogen. So if you have an unidentified molecule and it finds that it only has carbon and hydrogen, you have found a hydrocarbon. Hydrogen and carbon. That's what all of these are up here, hydrocarbons. And now on to page 2 in the textbook, chapter 3, section 2. Hey, two molecules have the same molecular formula, but different structures would be referred to as isomers. That was on the last page, even though it says the answer is on page 42. Question 6 is an isomer. If they have the same formula, the same number of atoms, but one is in a branch, one is in a long chain, then they are similar. So they're called isomers. Now let's complete the chart with what you see right here. So go ahead and fill in the chemical group name. The first one is done for you. A hydroxyl right here has an OH group. Now in the chart on question 7, write down what the structure is for a carbonyl, a carboxyl, an amino group, a phosphate group, and a methyl group. And they're listed right here. So go ahead and put that chemical group into the chart. Everybody got that? Yep. To itself, other parts, which leads to great diversity in, I think it was structures. It's showing you examples of what it is and how it changes. So it goes back and forth. It's like a little option. You don't be really concerned about the elements forms. It just, if it contains nitrogen, it's called an amino group. I'll go over it up here. So, what did you write down for carbonyl group? A carbonyl group right there. You're going to write this. You're going to write C double bond to an oxygen. Right there. So that's what you write down over in this little box. A carboxyl group. That is a COOH. And they give you examples of what it would look like hanging off on the end of a carbon chain. So it's the very end cap. Like in a grocery store, you know, the end cap is at the end of the aisle, and then they stick stuff on the end, and so people can see it prominently. That's high valued real estate. So what if you are a vendor and you want to get your new product into the grocery store? This is already taken, like ecology. It's already land that has been colonized. So it's really tough for new products to get their stuff into a grocery store because the vendors have to pay a lot of money for high real estate. It's very visible. A lot of people walk by it. Not everyone walks up and down every aisle, but they do walk along the perimeter of the store. So it's seen more. And so that company has to pay a lot more money to have their stuff at eye level on the end cap. It's costs them less money to get their product on a lower shelf or on a higher shelf because people don't see it as often. And I'm just giving you an analogy of the end cap. So these are all end caps. The next one, amino group. It's got nitrogen in it. That's what an amino group is. So you're going to write down NH2. A phosphate group has phosphate. So right here it would have carbon, and the chain could be thousands of carbons long, but then at the very end, it has 4 oxygens attached to phosphate. And then a methyl group, it's also really common. It's an end cap that has a carbon with 3 hydrogens attached to it. Now, we're not going to go into a whole lot of detail about this chemistry. Just want you to realize that usually it's just carbon with some sort of end cap. If you are going to have molecules bond together, they have to get rid of the end cap, and then they stick themselves together. So we'll see examples of that when we get into the mitochondria and the chloroplast. So let's go to number 8. Which is the only functional group that is non-polar? When you have oxygen, remember with water, there's a lot of electrons hanging out there, so that's polar. So when you have hydrogen and oxygen, that's going to be polar. This has oxygen, so it's polar. This has oxygen, so it's polar. What's the answer? Which one is non-polar? It only has a positive side because hydrogen is there. Methyl group right here. Number 9. Molecules that are polar are called, what's the word for water-loving? And so we'll find it right down in the next page. I thought I saw it already. Yeah, there it is. Up at the top, right underneath the picture of the lioness. It's another key term, hydrophilic. I'm highlighting that. Good idea for you to do so too. So already we've had like 5 key terms in 2 pages. The sooner you know those words, the easier the entire unit gets. And this stuff builds on itself a little bit. Hydro is the word for hydrogen. And if you put on the suffix philic, that means lover. If you said phobic, that means afraid. So there is hydrophilic and there's hydrophobic. And the question number 9 is asking for, what do you call it if it loves water? Hydrophilic. Because they're attracted to polar water molecules because they're polar themselves. Being soluble in water is what it means. So if you have a polar molecule, water can surround it like it did salt. Remember sodium being positive, chlorine being negative? Water surrounds it because it's an ion that it's surrounding. So water likes to be attracted to things because it's got a positive and negative side. That's how things dissolve when water surrounds it. So being soluble in water means water surrounds polar molecules. That's a necessary condition for life. So blank molecules are blank in water. So polar molecules are soluble in water. So that 6th group, the methyl group, it's nonpolar and it does not dissolve in water. And now we're ready for the next page. So we started the class saying that these are huge molecules. Super long. not tens, but tens of thousands of carbons long. So imagine a big train with individual boxcars and how they link up. That's a carbon linking up to another carbon, making a really long chain. So this question right here, so teachers commonly use a train and its numerous cars as an analogy to help you understand monomers and polymers. The individual cars are monomers, mono meaning one, and a mer is a building block, one building block like a little Lego piece. You add another one together, now you have a dimer. You have another one, and now you have a trimer. And then you could have a quaternary mer. You start losing track, and you just start calling it a polymer, poly for many. So usually monomer, dimer, trimer, and then you just call it a polymer after that. So here we are. This is a good analogy because large molecules are called polymers, and they're made out of individual building blocks called monomers. And the words are right here in page 3 of chapter 3. So there are some more words for you to highlight. So you can call a macromolecule a gigantic molecule. And they gave you examples of those. Carbs, proteins, and nucleic acids. A polymer is the macromolecule. And the small building blocks are called monomers. So I highlighted all those three. You got to have those in your vocabulary. If you're going on a hike on a hot day and you didn't bring water, you're going to get dehydrated. Does that mean that you're losing water or you're gaining water? Yeah, right. Dehydrate means that you take water out of your body. So if you're taking water out of a molecule, it's called dehydration. And interesting, you have to pull a water molecule out of it if you want to put two molecules together. Remember the end cap? One is going to take a hydrogen off here, and another one's going to take the hydroxyl OH off of here. And so you're going to strip 3 atoms out of the ends, and you pull water out of it. You bring the 2 H's together and an O, and you got water. So in order to link up the boxcars of a large polymer, you have to pull the end cap off, and you've got the ingredients for water. It pulls a water molecule out of it. So that's dehydration synthesis. That's question number 11. Why is it called dehydration reaction? To put monomers together? Because you pull the components of water off the end caps of 2 molecules to bring them together. So remember, we got carbons here, and then we could have a carbon, then we could have a hydrogen, and we could have an OH. And then the other one would have a carbon, and then this might have like 3 hydrogens, a methyl group. So we can combine these two, but to do so, we're going to pull these out like that. And this becomes water. So to link 2 chains up, you're taking part of their end caps off, and you pull the water out. Can't you reverse the process? What if you wanted to split this large molecule in half and cut it right there? You would have to split up water and then use the ingredient of OH and put it there and H and put it there. So that is called hydrolysis. To lyse, L-Y-S-E, that means you take a machete and you cut it in half. Lyse means to split. Hydro is water. So to split water, to use the components to patch up the ends because they're broken. That's hydrolysis. So that is number 10. Why is it called hydrolysis? To break a large molecule into smaller pieces. So say something like this for number 10. We need the ingredients of water to patch the ends that are broken when you split a molecule in half. Because carbon can't just be hanging out there with 3 bonds, it needs 4 bonds. Hello.
Oh, this is from the table, so to you.
Great, thanks. Oh, so they have examples of it right here in the book. Right, isn't that what I drew? So here's one ring and here's another ring. If you want these two to be together like that to make a longer polymer from 2 short polymers, you have to take an OH and an H, and that strips out water. Hydrolysis, if we want to split this in half, we cut it, but now it needs to be patched. It needs to split water, take part of it there and part of it there. So isn't that cool how water's involved to either put molecules together or to break them apart? Water's readily available, and we're 66% water. Yeah? Say again? Number 10 or 11? Number 10 is hydrolysis. So here's the picture of hydrolysis. So it says, why is it called hydrolysis? If we're breaking this up, we also have to split water. So hydrolysis means to split water so we could use the components of water to patch up the broken ends of the polymer. They do a nice visual right here. And this is as detailed of the chemistry that we need to go into. But remember, your body is constantly, whenever you eat, you're eating macromolecules. Your body has to cut them all up. So it uses water to patch up all the ends. And then your body has all these monomers in the bloodstream. They go to your cells, and your cells are going to start to build them back up again. And when they're building it up, now they have to pull the water out of it. So your body is constantly using water, splitting it up, or forming water. So isn't that cool that you create your own water too? There are some animals out in the desert that don't even have to drink water. They get all the water they need from the food they eat. In their digestion, when they're breaking the molecule, they are actually creating water for themselves. Their small body size gets all the water they need just from their digestion. All right, let's finish up. Did I answer your question? And number 12, which of the following term best describes the following reaction? Glucose plus galactose, those are 2 sugars, yields lactose and water. All right, is water on the product side or the reaction side of the equation? For question number 12, water is over here on the right. Is that a product or a reactant? If something is on the right side of the arrow, it's a product. On the left are reactants. Remember that from the last unit? You had a question on the quiz on that? So if you produced water, is that dehydration, synthesis, or hydrolysis? What is it? Which one? Hydrolysis? If it was hydrolysis, the water would have been on the left-hand side as a reactant because you would have split it, and then the water would have disappeared into the products. But look, we created water. Water was created, so where did it come from? It got pulled out of those reactants. So the answer for 12, that's a dehydration reaction. See, if you're creating water like that, that's a product. So it dehydrated the water out of the 2 polymers when it made a large molecule. Now there's a 7-minute video right here that we don't have time to play, and we won't do this in class, but if you play this, it could be the thing that makes the light bulb go off over your head. Like, oh yeah, I get it. The first time you hear it, my gosh, you could barely keep your hands on the handlebars. You know, it's like you're riding a roller coaster and it's like, oh, enough already. I didn't get the last concept. Now I don't get this concept. And now I don't get this concept. But that's the first time on the ride, right? You go on the ride again, you go, all right, now I know it's going to go like this and like this and like this. All right. Woo, that was fun. All right, now I got it. Come on, ride with me. So you got to do things 2 or 3 times in order to make it click. And when you do these little videos right here, it really helps. So wouldn't it benefit you to look over these 3 pages before our next class? And we're going to start our next class with the with the MyFitnessPal. That assignment is already open for you. I'm going to click into it and show you what it is, but we're going to go over it together. So I'll go over here to modules. Oh, by the way, what we just finished, you can turn in. That it's due in a couple of days, but if you finished it, you should turn it in so you don't forget. So you'll find it under a test because this is going to be our test for Chapter 3. It's MyFitnessPal and Molecules of Life. This is pretty detailed. So I've got videos down here. 3, how do you enter data into this website or the app? We're going to go over this, but if you wanted to get a jump start, you can take a look at it. How do you get the data out of the program? There's a video for that. How do I turn it in? There's a video for that. There's also pictures on how you do a bunch of things. So it's going to be a ride like, oh my gosh, it's a lot to take in. That's why we're going to do this for 2 class periods. What's the goal? Well, you're going to register for a free account at this website. You're going to use your modern day email address and a birth date of 11/1/2000 to remain anonymous. And you're going to record all the food and snacks and everything you eat for a 24-hour period, down to all of the condiments. If you use ketchup, if you have salad dressing, what kind of salad dressing. And the app is really easy to use. It acts like a barcode scanner. I could take this and scan that code and it would have all the ingredients in this bar and it would be added to your nutrition. So you're going to track your macros and your micros for 24 hours. You guys need about 3,000 calories, so you have to record at least 75% of that. Some people are going to go, oh, I fasted that day. I only ate 2 things. No, you have to wait for yourself to eat a regular day's diet. You can't fast like that with 300 calories for more than a day. So we're going to be doing that app, and then there are pages of questions for you to answer. Remember, this is your quiz. It's got basically 15 questions in there, and the data out of your program, you're going to analyze your carbohydrates, fats, and proteins against a goal that is set for you by the government, basically, and the FDA, Food and Drug Administration. So you should know what your basal metabolic rate is, how many calories you burn just for breathing and keeping your heart beating. And then if you add exercise to that, your caloric intake requirements increase. So you're going to learn the science of your diet with this tool, which is amazing. It's got every food item that you could think of. All the food from Sodexo, that's the food here on our campus. All the food are there. So if you eat French fries, you would write Sodexo French fries. It would give you a list of what's in them. If you eat cookies, you would go Sodexo chocolate chip cookies, Sodexo pepperoni pizza, In-N-Out burger, double, protein style, large French fries, chocolate shake. You go to the movies and you get a large tub of popcorn, times 2 because you got a free refill and your large soda. And then you've got candy bars at the snack bar. So you can see what it does to your diet. You want to know why most Americans are overweight? Because they don't know the amount of calories they're taking in. Empty calories are called that because they only have calories. They only have energy in the form of glucose. And they lack vitamins and minerals. And they lack protein. So if you have a diet full of empty calories, then it means that you don't have the building blocks for the molecules that make you up. So you can stunt your growth. You can have problems with certain hormone and organs if you don't have the right building blocks for this. There are some molecules that you cannot make yourself inside your body, so you have to have them in your diet. So if you don't have them in your diet, you can't make certain things for your body that is required. So that's kind of where we're going with this. You're going to learn a lot about how calories in and calories out need to be balanced. You could have a goal of maintaining your weight, gaining weight, losing weight. It doesn't really matter what the goal is, but you should know how to scientifically work out how your body as a fine-tuned machine needs to get what it needs to run properly. If you don't maintain a car, then it's going to break down. And if you don't maintain your body, it breaks down sooner than later. There's a thing called your calendar age and your biological age, and the two don't have to match. So right now, you guys are 13, 14, 15. There is an app and a website that can show you what your biological age is. So you could be 25 biologically right now. A 50-year-old could be biologically 40 years old. A 30-year-old could be biologically 60 years old. So the age of your organs is dependent on the quality of the food and the nutrients that you have and your biological measurements. So there's a table that says how tall you are, how old you are, male or female, and it should tell you what you should weigh within a range. Your blood pressure should be at a certain range. Your heart rate, resting heart rate, how many times your heart beats per minute should be within the guidelines. So if they're not, it could be because of diet and exercise as well. But losing weight is not about exercise. So my wife works for a company that she helps people with their diet. She's a nutrition specialist. And she can help people lose 100 pounds without one bit of exercise. So losing weight is about getting your mindset. People get overweight not necessarily because they overeat, but why do they overeat? And that has to be addressed. Because after people go on a diet, then they just gain the weight right back again if they haven't fixed their head and how their nutrition should be for their lifestyle. So please check this out. We're going to go into this. Notice you're not going to use Notability. You're going to use Pages because you can expand it and you're going to insert different pictures. So that's what we got going on next week. Chapter 3. Yeah.